Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Squïsh Smörgåsbord. And this is by Chinstrap. And here are the rules. We have Sudoku, where we need to place the digits we need to fill every cell in the grid with a digit 1 through 9 so that the digits do not repeat in rows, columns, or the 3x3 boxes marked by the dotted lines. So this would be a 3x3 box here. This would be a 3x3 box here. This would be a 3x3 box here. Digits on dotted lines exist in multiple boxes. So this cell is part of this 3x3 box here, part of this 3x3 box here, and part of this 3x3 box here, and this 3x3 box here. So that's how Sudoku works. We also have line constraints, where digits on a Renban line, which is this line here, don't repeat and form a single consecutive run like 2, 3, 4 when sorted. So that's actually an interesting way of putting it. Do I like that better than normal? Maybe. That's not bad. As an example, you could have something like, say, 6, 8, 5, 7, 4. And this would be valid as a Renban because when you sort it, 8 forms a consecutive run, a single consecutive run. 4, 5, 6, 7, 8. So that's an example of how Renbans work. We also have GW, or German whisper lines, where adjacent digits along a German whisper line differ by 5 or more, or as I like to call it, whisper 5 lines. So for example, if this were, say, a 3, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how whisper 5 lines work. We also have Dutch whisper lines, where adjacent digits along a Dutch whisper line differ by 4 or more. And I like to call them whisper 4 lines, because it makes it very clear what they are. So for example, if this were a 3, these would have to be 7, 8, or 9 as possibilities, because those are the only possibilities, the only digits which are 4 or more away from 3. So that's how Dutch whisper or whisper 4 lines work. We also have parity lines, where digits on a parity line must alternate between odd and even. So say this was an odd digit, say it was 3, then these digits would have to be even. So they could be 2, 4, 6, or 8 here. And that's an example of how parity lines work. We have a modular line, where the modular line must have... Okay, so it's only 3 in length. So the modular line must have one digit from each 147, 258, or 369. And it's called modulo. Maybe it should be called modulo lines, because essentially they are 1 modulo 3 set, 2 modulo 3 set, or 0 modulo 3 set, right? 147 when divided by 3 gives you a remainder of 1. 258 when divided by 3 gives you a remainder of 2, and 369 when divided by 3 gives you a remainder of 0. And you have to have one of each set on this modular line. Similarly, we have an entropic line, where the entropic line must have one from each of 1, 2, 3, 4, 5, 6, and 7, 8, 9, which is a low, a middle, and a high digit. And for the other constraints, we have an X, where digits on an X, which is in box 1, sum to 10. So for example, if this were a 3, this would have to be 7 to add up to 10. And then we have a V, where digits on a V, box 3, sum to 5. So say this was 3, that if this is 3, this would have to be 2, because these two must add up to 5. And finally, we have odd and even digits, where the digit in the circle, row 1, column 4, is odd, and the digit in the square, which is row 7, column 4, is even. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, to add up to 5, you'll have 1 through 4. So this must be 1 through 4. This must be a low digit then. And low digits are next to high digits on a Whisper 5 line. Because what digits can be next to 1 through 4? 4 can be next to 9, 3 can be next to 7, 8, or 9. 2 can be next to 7, 8, or 9, and 1 can only be next to 6 through 9. So next to a low digit, you'll always have a high digit. So this must be high here, which makes this low, which makes this high, and this low. So this must be 1 through 4, which makes this 6 through 9. So this is a high digit. This is next to 2 unique digits on a Whisper 5 line, so it's 7, 8, or 9. Same here, this is 1, 2, or 3. This must be then 7, 8, 9 here. 1 through 3 has to be next to 5, 6, 7, 8, and 9 on a Whisper 4 line, or a Dutch Whisper line. Okay. These must be the same parity. So in box 5, you're guaranteed 8 digits, which must be of even and odd parity. So that's 4 each. Therefore, this must be an odd digit here. So this is 1, 3, 5, 7, or 9. We are guaranteed on this Renban line a 5. So one of these is 5. This is odd, so this must be 1, 3, 5, 7, or 9. This is even, so this is 2, 4, 6, 8. Okay. These are all the same parity. So if this was even, you'd have 6 and 8, 6 and 8 here. But that would mean these would have to be even also. So therefore, they would have to be 2, 4. But I don't think that's possible at all. So say this is 6 and 8. This would be 2. One of these would be 2 or 4. The problem is they would both have to be 4 or more away from the same digit. But that's not possible, right? 6 can only be next to 1 or 2. 4 can only be next to 8 or 9. 8 can only be next to 1 through 4. And then 2 can only be next to 6 through 9. And none of those overlap. So this cannot be even digits. Therefore, this must be odd digits. So these must be odd digits here too. So we have all the odd digits already in box 5. So these are odd. These are even then, which makes this odd. Similarly, if say this was 7 and 9 here, and this was 1 and 3. The problem is 7 can only be next to 1, 2, or 3 on a Whisper 4 line. And 1 can only be next to 5 through 9 on a Whisper 4 line. I think we're almost guaranteed that a 5 has to be one of these two digits here. So one of these is 5. Oh, in fact, it has to be, because we have 2 digits, which are 7, 8, and 9 here. If we try to have a 7-9 pair here, this box 2 would have 4 digits, requiring the digits from 7, 8, and 9, which is only 3 digits, so that's not possible. So this must be 5 here, which eliminates 5 in the rest of box 5. And we have, this is guaranteed to have an 8 here somewhere. So that eliminates 8 in the rest of that box. This 5, 7, 9 triplet eliminates 5, 7, so this is 7, 8, or 9. One of these is 8, the other one's 7 or 9. This is 5, with one of these being 7 or 9. That eliminates 5, 7, 9 in the rest of the box. So this is 1 or 3 here. So we're guaranteed 5 is here. Okay. Um. Hmm. Okay. We're guaranteed a 5 here. We don't know anything else. Huh. This is even, that's even. This could be 5 here. We're guaranteed one of these is low, right? Because this cannot be high. Can't be one, sorry, cannot be low here. Only one of these could be 1 or 3, so we're guaranteed at least a 1 or 3 here. So this must be 5 through 9 here. And yeah, it could be 5 next to 1 and 9. That is potentially possible. Hmm. Okay. We have 1 low, 1 middle, and 1 high in box 6. Oh, since one of these is 5, that guarantees this has to be a 1 here. Because 5 can only be next to 9 or 1 on a Whisper 4 line. So this is 1, which makes this 3. This can't be 1 anymore. This can't be 1, so this can't be 9. This can't be 4. This 3 eliminates 3 here, so this can't be 3, which means this can't be 2. So this is 3 or 4, which means this cannot be 7 anymore. This is 8 or 9. 1 and 3 eliminate 1 and 3 here. Where is the 1 and 3 in box 5? It has to be here. So this becomes a 1-3 pair here. That means this digit has to be 4 or more away from 1 and 3. So this is 7, 8, or 9. So this cannot be 5. We are guaranteed at least a 7. So this is either 3 through 7, 4 through 8, or 5 through 9. So this has to be 3 through 9 as possibilities, but this can't be 3, and this can't be 3 because of the 1-3 pair in box 8. If this is 5, this would have to be 9 here because it's next to 1 or 3. So if this is 5, this has to be 9. If this is not 5, it's 7 or 9. I think it has to be 9 here in that case. If this was 7, that could only be next to 1, 2, or 3 here, and those are not going to be 4 away from 1 or 3. So this must be a 5-9 pair here, which eliminates 5 and 9 in the rest of the central box. So this is 7. 5 must be next to 9 to be next to 1 or 3. And 9 must be next to 5, which must be next to 1 or 3. Okay, so this is a 5-9 pair, which eliminates 5 and 9 in the rest of box 2. This can't be 9, so this is 8. This can't be 8 or 9, so it's 7. 7 can only be next to 2 on a Whisper 5 line, so this is 2 and 8 without a 1. 8 can only be next to 3 out of 3 or 4, so this must be 2 then. So this is 2, 3. We have 2, 8 here. This cannot be 8 here. This can't be 3. The 7 eliminates 7 here in the rest of column 7. This 8 eliminates 8 in the rest of column 5. So this is 8 or 9. So you guaranteed cannot have a 3 on this red band. It's either 4 through 8 or 5 through 9. Okay. So that means either way, we have a 5, 6, 7, 8 guaranteed in these 5 cells. So this must be 1 through 4 or 9. We don't know in the rest of row 6. Let's see. Okay, remaining digits. So 2 cannot be in either of these spots in box 2. Where is the 2 in box 2? It has to be here. That eliminates 2 in the rest of box 5 and the 2 in the column 4. We have a 5-9 pair in box 4, but that doesn't help us much. We have a 5-9 pair in box 6, but also that doesn't help us much. Remaining digits in box 2 are 4 and 6. We have a 4, 6, 4, 6 pair in column 5, which eliminates 4 and 6 in the rest of the column, so this cannot be 4 or 6. We know we have a 2 guaranteed in one of these 2 spots there. Okay. Okay. We are guaranteed a 4, 6 here, which is a mid. 5 and 9, one of them has to be here, which means the other mid has to be here. So this cannot be mid. It's 1, 2, 3, 7, 8, 9. But it can't be 9 because of the 5-9 pair in the box. This can't be 2 because of the 2 in the row. This can't be 1 or 3 because of the 1-3 pair in the row. One of these 2 is 8. Where is the 2 in box 4? Cannot be here, cannot be here, or cannot be here because of the 2's in the column, the rows, and the boxes. So 2 has to be one of these 2 digits here, which means this cannot be 2. Where is a 2 in box 6? Can't be here, can't be here, can't be here, so it's one of these 2 also. So this can't be 2 either. Okay. This is a guaranteed low. We have a guaranteed low here. But that doesn't help much. This is guaranteed high. This is high. Modular lines. Where is the 2 mod 3 modular line in box 4? Cannot be either of these because we're missing 2 and 8 here, and the 5-9 pair precludes that from ever being 5. So the modular line in the 2 mod 3 digit on this modular line has to be here, and it's 2 or 8. Okay. That means the other remaining digits are 1 modulo 3 and 0 modulo 3. So we have 1, 4, 7, 3, 6, 9. Obviously can't be 9. 1, 3, 4, 6, 7. Can't be 9. This can't be 1 or 3 because of the 1, 3 pair in the row. So this is 4, 6, or 7. This is 1, 3, 4, 6, 7. This cannot be 1, 2, or 3. So this is 4 through 9 here because of the 2, 3 in the column and the 1, 3 pair in the row. So this is 4 through 9. Cannot be 5 or 9 because of the 5, 9 pair in box 6. So this is 4 or 6, or it's 7 or 8. This 8 eliminates 8 as a possibility here because it's in the same box. This 7 eliminates a 7 as a possibility here because it's in the same box. Remaining digits in row 1 can be 1, 5, 7, 9, but this can't be 7 because it's 7 in the box. 1, 5, 7, 9. Remaining digits in row 2 could be 4, 5, 6, 9. This 3 eliminates 3 as a possibility there. Wait, why? Where did I get that? I don't even know. I'm not sure where I got those numbers from. Where did I... Oh, right, because it can't be mid. You can't have a mid and you can't have 5 or 9. Okay, that's the reason why. And then 2 and 9 are removed. This can't be 3 or 8. Okay. Right, so this is 1 or 7. Hmm. Hmm. Okay, this digit cannot be... Okay. Hmm. These digits cannot be 5 or 9. So we have what? 1, 2, 3, 4, 6, 7, 8. This can't be 2 or 3, obviously, because of the 2, 3 in the box, or the column. This can't be 8 because of the 8 in the box. This can't be 7 because of 7 in the row. Hmm. Hmm. Remaining digits here. Cannot be 2, 5, or 9. We have 1, 3, 4, 6, 7, 8. No 7 or 8 here because of the 7 or 8 already in the box. 3 has to be one of these digits here. So this is guaranteed to be 3 because there's no other place for it in box 1. Since 3 is guaranteed to be one of these two digits here, it cannot be here. So this must be 1, that's 3. 3 cannot be next to 5 on a whisper 4 line. So this is 9, that makes this 5, which makes this 9, which makes that 5 on the whisper 4 line. This 9 eliminates 9 in the rest of box 1. This 5 eliminates 5 in the rest of box 1, or box 3. This 5 eliminates 5 here. And this 5 eliminates 5 here. In column 5. Remaining digits possible then in column 5 are 1, 2, 7, and 9, I believe. But this can't be 1 because of the 1 in the box already. So 2, 7, or 9. So we have 1, which eliminates 1 as a possibility here in box 4. Where's the 1 then in box 1? Cannot be here, cannot be here, cannot be here, so it must be here. So this is 1, which eliminates 1 here. So one of these two digits is a 1 for box 3, which means this can't be 1 because we're guaranteed a 1 here. This 3 eliminates 3 here in the rest of box 6. Okay. We have a 3, 4, 6 triplet in box 1, which eliminates 3, 4, 6 in the rest of the box. So this can't be 3, 4, 6. It's 5. This 1 eliminates 1 as a possibility here. This 3, 4. So we're guaranteed these are 3 distinct different digits, and they're all 3, 4, and 6. Well, these see this cell because they're in the same box. This sees that cell because they're in the same column. So this cannot be 4 or 6. Therefore, this is 8, which means this can't be 8. This is 4 or 6. This 8 and 9, the 7, 8, and 9 eliminates 7, 8, and 9 here in the rest of the column. This can be 2, 3, 4, 5, 6. It's a possibility, but it cannot be 3 because we already have a 3 in box 8. 5 is guaranteed to be one of these two digits here because it cannot be here. It cannot be any of these digits. This can't be 9 because of the 9 in the column. So since 5 is here, that's fine. 3 is guaranteed to be here. We have 1. Remaining digits in box 4 are 2, 3, 4, 6, 7. Cannot be 3 because of the 3 in the row. These 4, 6 pairs both see the cell. This is in the same box. This is in the same row. So this cannot be 4 or 6. This is guaranteed to be 7 or 8, which is a high digit for the entropic line. That eliminates the rest of the high digits in the rest of this entropic line. So this cannot be 7. This can't be 8. Okay. Whatever 4, 6 is here. Okay, so this, we're going to start coloring these different ones. So we're going to make this orange 4, 6. We'll make this yellow 4, 6. That makes this yellow 4, 6, which makes this orange 4, 6. We can remove the red and blue because that's not helpful right now. This orange 4, 6 means, okay, so these 4, 6 both see this cell. This is in the same box, box 3 here, and this is in the same box, box 6. So this can't be 4 or 6, it's 1, which forces this to be 7, which makes that an 8. This can't be 7 or 8, so it's 2, which means this can't be 2 here. So this is a medium digit. This must be the yellow 4, 6. The 7 eliminates 7 here, so it's 9. Therefore, this cannot be 9. This is the orange 4, 6, which eliminates 4, 6 in the rest of column 7. This can't be 4 or 9, so this is 1 or 3. 3 eliminates 3 here, so this is 1. This can't be 8. The remaining digits in column 6 are 4, 5, 6, or 7. Okay. This 2 eliminates 2 as a possibility here, so this becomes a 7, 9 pair, which eliminates 7 and 9 in the rest of box 9 and the rest of box 8. So this can't be 9. This is 8, which means this can't be 8. This is the orange 4, 6, These both see this cell because they're in the same box. So this is 5, this is 2. This 2 eliminates 2 here. So where is the 2 in box 4? It has to be here. So this is 2. This is a modulo line. This must be the orange 4, 6. This must be the yellow 4, 6. This 5 eliminates 5 here. We don't know which 4, 6 or this is. So this, okay, this orange 4, 6 eliminates 4, 6 in the rest of box 9 here. So this must be orange 4, 6. Yellow cannot be here. Where is yellow in box 9? It has to be here. So this cannot be 5. This is a 4, 6 pair, which forces this to be 5 here. Where is yellow in box 7? Cannot be here, cannot be here. Therefore, it must be one of these two. Okay. Where's the 8 in box 7? Cannot be here, 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 or here, so it must be here. Remaining digits, remaining digits in row 7 could be 1, 3, no 2, 4, 5, 6, cannot be 8, so it's 1, 3, 7, 9. This can't be 1 because we already have a 1 in box 7. This is guaranteed to be 7 here, so that eliminates 7 in the rest of box 7. So this can't be 7. We need a 7 on this red band to be with 5 and 8. This has to be 7 then, which forces this to be 9. This 9 eliminates 9 here, so it's 3, which means this can't be 3 here. This 3 eliminates 3 here. So this is the yellow 4, 6, which makes this 3. This cannot be the yellow 4, 6 then, because we already have a yellow 4, 6 in that column. So this must be the yellow 4, 6, and then all the yellows are 4. That leaves this as... So this cannot be 4, and it cannot be 7 because of the modulo. So this has to be 0 modulo 3, so this is the 6 and is the orange. So this must be 7. This 4 and 6 eliminates 4 and 6 here, so this is 9. So all the oranges are 6. And that's a solution. Yeah, fairly straightforward for Squïsh Doku. I haven't actually done very many Squïsh Dokus. I'm not the biggest fan of them, but it was always kind of interesting to see what they can be, right? And what restrictions you have there. And this had a good rating, so I was curious to see what it was. And it flowed very well. It was a very nice puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.